Alright, we are continuing factoring polynomials or expressions. This section is about factoring special expressions called trinomials. Let's mark this. Factor means breaking up. You're going to break trinomials into pieces, parentheses, breaking into parentheses. But what is the meaning of trinomial? You see the tri? What's the meaning of tri?
3.
Yeah, means 3. You expect to see 3 items. 3 items on the form with a square term, x term, I call it x only term, and no x, we call it constant term, such as x squared plus 10x plus 21. So in the problems, you will be presented this, you will be given this. X squared 10x plus 1, 3 items, but the signs between them, it seems like, is it always positive? No, these signs can change. If b is a negative number, plus negative 3x is actually minus 3x, x squared minus 3x, so these can flip. With pluses and minuses, you will be presented 3 terms. So what are we going to do? You will be given this. What you need to achieve is this. You must find this in the homework questions. It's all like this. You're given 3 terms, added or subtracted. You're turning them into product of 2. Alright, if this is called trinomial, what is this called if there are only 2 terms in each? They are called binomials. So our task is to change one trinomial into product of 2 binomials. Got it? 2 items on each. X plus something, X plus something. That's it. All done. Okay? One great thing about this section, or easy thing about this section, is, clean this. What do you see in front of X? X squared. Do you see anything here? Right here? That means, what's that?
Positive 1.
It's 1. If you don't see anything, that means that leading coefficient of x squared is called 1. This is a special trinomial. It's a trinomial with leading coefficient 1. And this is, I call, easy. When you go to 6.3, we will still have trinomials, but there you will have this number turned into another number like 2, 3, and something else. They are not going to be that easy, okay? But learning easy way, we need to first practice easy way, because we are going to build on this present way to make the next section, okay? So you are going to get more tricks there, but you need to first learn how you do it with a single one. So in an exam or quiz, first thing you need to check is how many terms you have. 3 terms. When you see 3 terms or trinomial, go and check the first term. Is it 1? You can relieve and say, whoo, this is easy, okay? But if it's not 1, don't worry, we have special methods for it. I will show you. But let's first enjoy the easy way. So what is the trick here? How do I go from right to left? To see the trick, why don't we first FOIL this thing, multiply first terms, outside terms, this is F, this is O, outside, inside terms, and last terms, L, I, and L. This is called FOIL. When you FOIL it, first terms multiply to x squared, last terms multiply into 3 times 7, 21, but the inside and outside terms make 7x and 3x. This is O, this is I, F, O, I, L. What we observe here is that when I add these 2 guys, 7 plus 3 is, I get the middle term, 10x. And 21 is product of the last terms. So this gives me the idea. I observe a method to break this 10 and 21 into pieces. When I'm breaking this into 2 groups, I will pick numbers here. I will pick two numbers here. These are question marks. But those two numbers should multiply into 21. Multiply to 21. But when I add them, add to 10. So this is a puzzle with two statements. You're answering a puzzle question. Guess two numbers that will multiply to positive 21 and add to 10. What two numbers can it be? Can it be 1 and 21? Because 1 times 21 is 21. Can it be 1 and 21? Maybe.
7 and 3.
Yeah, you already know the answer. Great. But 1 and 21. 1 and 21 doesn't make it because 1 plus 21 is 22. It doesn't make 10. So it's 7 and 3 as your friend said. Because 7 and 3 makes 10. So there may be so many options multiplying into the last number like 21. But there is only one pair also meeting the middle term when you add those two numbers. Got it? So we are ready for our first question. I want you to break this into two parentheses. I already start with these. These are x's, x and x. Why is it x and x but not 3x and 5x? Why? Can anyone tell me why is it single x and single x on each parenthesis?
X squared.
Because it's just x squared. It's just one. You have a single x squared. If you have 3 and 5, you multiply them, it makes 15x squared. It's too much. That's why we distribute 1x to the left, 1x to the right. That's how you break x squared. Okay? The question is, that's the easy part. How do I figure their accompanying numbers? Okay, these two numbers should multiply to 15. Then you multiply them. When you add them though, they must make 8. So, product will be 15. Sum will be positive 8. Make sure you put the signs as well. Signs matter. Because sometimes they can be negative. So all you need to do is trial and error. Play a game. Pick two numbers that comes to first your mind, making 15, product making 15, and see if it's making some 8 as well. So tell me, what two numbers multiply into 15? Any two. Now you're giving me the right answer. Start with the false ones. Like, what's the lowest number that can divide 15? 1. Naturally 1 and 15, right? 1 and 15 makes 15, right? But is 1 and 15, when you add them, make 8? What does it make? Positive 16. So this is wrong. So skip the next one. How about 2? What other, I'm increasing slowly. 1 to 2. Can you make 2 times something into 15? Does 2 divide 15? No. So we skip 2. How about 3? Yeah, 3 times 5 is 15. But when you multiply, add 3 and 5, do you get 8? Do we get positive 8? Yes. And you put check mark here. You found those two missing pieces. First one is 3. The second one is 5. Oh, wait a minute. Which one goes to the first? Which one goes to the second? Can I say it's first 5 and then 3? Which one is correct? Where does 5 go?
Right. On the right.
Okay, what if this was 5 times 3? It's still 8. So there are two solutions, right? So if you go with 5 first, then 3 next, it's still 8. 3, 5 is still 8 when you add them. Add, right? So which option is correct? Either one. So you can actually flip this. Either one answer is correct. Okay? Like, what is 2 times 3 and 3 times 2? Can I flip these two and make 3 times 2? Yeah, it's still 6. So you can flip 3, 5, and 5, 3. In these questions, in only this section, if you have this thing 1. If it's something else, you cannot flip. Alright? Important. That's important because it's like can I flip the locations of these two? Yes. All right, that was our first one. We call it is not. If it's splitting into two groups, it's not prime. It means it's factorable. Prime means you cannot factor it. Next, the pieces factors you found is x plus 5 or 3 first. It doesn't matter. And x plus 3. Any questions? Are we good? Okay. Before going to this sign, oh, now you need to do the sign rules first. Okay. Unfortunately, you won't have always positive here and positive there. You may have variation of signs, like the middle sign is negative, the right side is positive, or the middle side positive, right side negative, or both negative. So there are 4 cases can happen in a trinomial. Both positive, both negative, first positive then negative, or first negative then positive. 4 cases. This table tells you what happens, how you decide the signs in each case. You're under no obligation to memorize or use this table. You can still make your answer correct by just keep trying and trying each and every option. That's fine. You don't have to. This just makes your life faster if you have it on the side. Again, if you have both signs positive, you have these two positive, both numbers positive. If you have the middle sign negative, last sign positive, you choose both negative. Okay? And choose any two numbers, multiplying into 8 and adding to 6. However, if the last number is negative and the middle number is positive, then you need to go with one positive, one negative, but bigger one should be positive. Big number should be positive, so you can subtract them and get positive 2. And once both negative, you choose the big number negative, small number positive. Alright, again, I won't be using this table. I'm just giving you an extra source to help you to check your final answer is right or you're on the right path or not. Okay? I won't be using though. Alright, so let's test if you still can use this table. Again, if you have a trinomial, but these are positive, B and C are positive. This is positive. That's positive. What kind of signs do you expect in your answer? Each one says positive. It's C. Both should be positive. Okay? Both. It should be x plus a positive number, x plus another positive number. It's C. However, if it's also the same. Yeah, these two questions are this. Oh, no. They're not the same. B and C are positive, but you have a negative in front, so this is a negative number, so it's negative now. Negative, and this one is negative as well. It's both negative. If they are both negative, which option can be right?
A.
It's
A.
It's A. Because if you have both positive and both negative, this will end up getting the last number both positive, because you have a number here, a number. If you multiply both positive numbers, you will get a positive number. Or if you multiply both negative numbers, you will have a positive number on the very end. So it's a violation to C being minus C being negative number. So the only option here is A. One should be positive, the other one should be negative, so you can have a negative number on the end. It's just checking reasoning. Again, why is part B and part A is wrong here? when I multiply positive and negative numbers, the result is negative. This thing is positive. You may say, oh, wait a second. These two also make positive c, right? Negative and negative multiplies to positive c, right? So this could have been the right answer, right? Is that correct? But what happens if you add two negative numbers? When you add these two negative numbers coming up here, do you get a positive answer? No. Middle term becomes negative if these are negative. Alright? So this is a violation. That's why we didn't go with it. Alright, here comes one application. Again, feel free to use this table. Actually, it makes it really useful if you use this table. Now, I will assume I don't know that table and see how I'm going to find this out. First of all, figure out what product. You're going to pick a pair of numbers. You're going to come up with a pair of numbers. Product will be what? Those two pairs? M something, M something. Their product will be what number? Two numbers here. Their product will be 8. Yeah, it's this number. And sum will be this number. Okay, this one is tricky. Now, let's start with the smallest number that can be a factor of 8. What is that? 1. I choose 1 and 8. 1 times 8 is 8. So it can be 1 and 8 here. But when you add positive 1 and positive 8, what is the total? 9. That means this guy is wrong. Okay, what is the other option? 2 and 4. Positive 2, positive 4 makes 8. Perfect, I like that. But when you add these two, what do you get?
-6.
No, you don't get -6. Positive 2 and positive 2, 4, you
But isn't your signs, won't they be negative?
Hmm?
Won't your signs be negative?
Yeah, but right now we have positive signs. So it's if it is positive signs, the total is 6. It's wrong again. Now, but you feel, oh my God, it's almost the same except signs are different. How can you fix this? You almost got the right answer except you got the opposite side. The way you can fix this is choose opposite of this. Or can I go with 1 negative, 1 positive? What happens to 1 negative, 1 positive? It's when you add, it's positive 2. No, it's not the right way to fix it then. It's not 1 negative, 1 positive. And besides, what happens if you multiply -2 and positive 4? Their multiplication is, it's not making this thing. This is positive. So this is completely wrong. You don't even try flipping signs to 1 negative, 1 positive. We need to flip both signs. Try -2 times -4. What is -2 times -4? Positive 8. But when you add them, you get, what is -2 add -6? It's, no, I'm sorry, -4. It's -6. Is that match? Yes. So mark this. You caught the right pair right here. This is your answer. I'm going to go back and put -2 where? Anywhere you wish. It can be first or second. And the second one down -4. Okay? Okay. I want to show you another notation. Some people like to do these questions with this method. They put a cross. They put this number down here. This number up here. You just need to find two numbers here it's going to multiply to this, multiply two numbers, but add to these numbers, add to this number. What two numbers can I use here? Addition is -6, multiplication is 8. It's just a different way of putting numbers. Instead of making this trial, you're making trials here. You try first 1 and 8. Yeah, 1 and 8 makes 8, but is 1 and 8 adding to -6? No, switch it. Okay, is it 2 and 4? 2 times 4 is 8, but +2 and +4 is not adding to -6. No, switch it. And then I try -2 and +4. No, it's not adding to -6, or it's not multiplying to +8. No. Then I try -2, -4 eventually, and I get -6 addition and +8 multiplication. Voila, we got it. Okay? Any questions? Are we good? Oh, I should have. Too late. It's not prime, okay? It's not prime because we factored it. We split successfully into two pieces. It's called not prime. M minus. Which one is first? 2 or 4? It doesn't matter again. I don't know how I made this underscore thing, but let's see if I can clean it. There you go. Yeah, it's up now and -2. Check. Now we got the second half right. Okay. All right. I want you to try this on your own for a second. Just you need to find two numbers. Okay, I'm going to use this symbol. Alright. Product will be -8. Product. And sum will be -2. What two numbers does that? It's similar, right, to this question? 8 at least. Any volunteers? Any first answer?
-4 and +2.
All right. -4, +2. Always verify here. Multiply this. Is it -4 times 2? -8? Is it? Yeah. When I add them, do you get -2? Yes. Congratulations, you got it. Okay. All right, next. What the heck this means? All right, I will assume I didn't see anything different. We will do the same thing here, right? The last number is -140. Product. And sum is, what is the sum? Past 15. Tell me two numbers multiplying into 140 and adding to 15. Yeah, maybe you can do that. Any volunteers?
Do you have to get rid of the 5 on the other side?
Okay, I didn't hear that answer. Okay. Just yeah. So your friend already noticed that there is a 5 in front of the square term, which wasn't anywhere in the previous questions. Do you see any numbers in front of x squared other than 1? I don't see. But yes, one thing we notice in this question when I see that this trinomial is This is not 1. That means forget all the things I said this morning. You can't do this. This is impossible. Don't even try to attempt it. It's wrong. You can't. This won't work for this question. You need a brand new idea. But before getting into brand new idea, which is in 6.3, we are going to see that. Why don't you try this? Is there a way I can separate this 5 from y squared? It looks like 5 and y squared glued together, but can you keep it aside?
Divide 5 on all terms.
Yeah. It's actually clear from the statement. It says this is actually a hint. It may be covered maybe in the test. You may not see this, okay? But hint. It says if there is a greatest common factor, that the number that is a factor of everybody, separate it out. So I see that 5 is in every family. There are 3 terms here. Everybody has common factor 5. So I can divide everybody by 5. So 5y squared is now 1y squared. And 15y loses one of the y's and drops to 3y. And what happens if you divide 140 by 5? It is
28.
28. Perfect. Okay? Now look at this question again. Only this part though. Forget 5. 5 is history. It's gone. It's left out this neighborhood. 5 is gone. What kind of trinomial is this now? It's a perfectly fine leading coefficient 1 trinomial we've been solving all morning, right? So you can do this method. Now for this part I framed, not that 5. 5 is out. Keep that 5 out here. But this frame is going to now split into 2 pieces with 1y on each. The other 2 numbers will be found by working out here. But what numbers new numbers are you gonna put? Is it still minus 140 and 15? No, they are no longer the same in this frame. It's 3 in here and minus 28 on the end. 3 and minus 28 now. Look. Okay? So, anybody now who can tell us product of 2 numbers you're gonna put left and right, 2 numbers, gonna make minus 28, but some will make 3 only. Negative 7 and 4. Is that right? Always double check. Multiply these. 7 times 4 is 28, negative 28. Negative 7 plus 4 is negative 3, so this is wrong. It's not adding to positive 3. Good answer though. I like this. Because this happens a lot in the exam. You guys aim to get 3 and 28, but you forget about the minus and positive signs. Yeah, they make 3, but negative 3. This is positive. So how can you revise your answer? You're actually close. Yeah. Instead of negative 7, just flip the signs. Make positive 7. Instead of positive 4, make negative 4. Now check again. What is 7 times negative 4? Positive 7 times negative 4? Negative 28. Check. 7 add negative 4 is positive 3. Check. Both checked. So you're just going to place positive 7 and negative 4 here. And done. Be done with it. Okay? Any questions? Okay, what's the story here? First thing I notice is, oh my god, this question has the same statement. Be sure to factor out the GCF. When I see that, I'm alert. Okay, I need to find something then. But that's the first reason I see something awkward in this question. Second reason is, once you are given a trinomial, check what? What do you check first? again?
1.
Yeah, if the number in front is 1. Is this 1? Is it 1? You may say yes because it's close, but it's actually negative 1. So negative 1 is not good either. Just like 5, negative 1 is bad. It's because it's not 1. Okay? So how can I get rid of that negative sign? Yes, when you see negative 1, you need to act and get rid of that negative. We need to, you said divide? Divide all things by negative. In other words, we need to factor that out again. Just like you factored out 5, right? Here, you pulled 5 out from all 3 guys. Now we are going to pull a minus 1 out of everybody. So what are the new inside terms then? What are they? Negative?
No, it's just these squares.
Yeah. Once this guy loses a negative, it turns into positive 1z squared. How about 9z? They won't lose nothing, right? They still 9z and 90, right? Only the first guy loses a minus, correct? Am I right? I'm right? So I'm seeing some approvals from guys. Am I right? Yeah, sure.
You gotta change the signs.
No, I'm wrong. I'm wrong because when I distribute this sign back, minus times positive 9 is not positive 9. So I must flip these signs as well. Everybody switches signs. So it has to be negative 9z minus 90. Okay, now next, focus on this area. You need to break that area into 2 pieces. You're gonna make these guys into 2. What happens to this minus then? It just stays out there. It stays out there. You just need to break this into 2 pieces by this method. You need to make minus 90 when you multiply product, and sum will be minus 9. Again, minus 90 and minus 9 goes here and there. Alright, this one is a little bit tricky because big numbers, there are so many pairs you can make, right? So many pair of numbers can multiply to this 90, like 45 and 2, 9 and 10. What else can you think of? 5 and 18. I can't find the right pair. Which one multiplies into 90 and adds to minus 9? Help, please.
Negative 15 and 6.
Negative 15 and 6. Positive 6, negative 15. So this one is a little bit hard to search. So how can I catch this? So some people can see, oh my god, it's 15 and 6. There you go. But I know some of you guys having a challenge. So my recommendation is if you can't catch that pair quickly, just go slowly with each and every number. Like you're gonna make 90, negative 90, and negative 1, right? Negative 10. Oh, sorry. Negative 90 and negative 9. Just go with 1. 1, 2, 3, 4, 5, 6, 7. Do we have 1 and another number multiplying into 90? Yeah, 1 and 90. Do we have 2 multiplying with another number to 90? Yeah, 2 and 45. 3, 3 and 30. 4, there is no number multiplying with 4 and 90. Just take a calculator and try to divide 90 by 4. It is 17 and a half. That doesn't make it. So this is not even an option. 5. Do we have a number multiplying with 5 to 90? Just divide. Oh, it's 18. Okay. How about 6? Do we have a number multiplying with 6 to make 90? Yeah, it's 15. So this way, check everybody and their opposite signs. 190 makes 91. No, wrong. Oh, I need to make minus 10. So you need to flip the sign flip the signs, and check everything if you can get this. So this is a lot of trial. Multiply positive, multiply negatives, and all options. A lot of you need to do trial, but eventually you will catch the right pair. It was positive 6 and minus 15. This makes minus 90 when you multiply, but when you add them it makes minus 9. This is the right pair, and there is only one pair that can make this, okay? Alright? You need to go slowly sometimes if you are struggling. But how come this doesn't make sense? Because when I add this, they make large numbers, not like minus 9. Or when I add them or subtract them, they all around minus 20s, 30s. It's not even single digit. This is a single digit. So you can eliminate the big digits like this. 90, 45, and 30 won't make 9, single digit 9. They are too far off. So I know two numbers should be close enough. 15 and 6. 5 and 18 is a good candidate as well. Okay? So check 5 and 18 as well. 6 minus 15 is the right choice though. So Z minus 15 and Z positive 6 are the right pairs. Minus was it minus 15? All right, and the last question. Oh, this one is pretty easy. This just says, I don't even put it here. This just says they already factored some polynomial. Says when you expand this out, what polynomial does it make? Y minus 2, y plus 15. It makes a trinomial when you expand this out. How do you find it? You just need to F O I L. What is it called? Foil. You need to foil it. F is y squared. O is y times 15, 15y. I is minus 2 times y, minus 2y. L is minus 2 times 15, minus 30. So is this the answer you're going to enter?
No.
No, we need to combine like terms. These are always needs to be combined. The answer should be trinomial. This is not trinomial. I see 4 terms, not 3. So we need to combine this. 15 take away 2 is 13y minus 13, 30. So this is the answer we're going to provide. So this is the backwards of all questions we did so far. We were given this and asked always to get this. Now you're doing things backwards. You're given a factored form. We are getting the whole polynomial out of it. Okay? So they are switchable. That's what I'm trying to prove here. You can get from factor to trinomial, trinomial to factor. Alright, any questions about basic factorization skills? So far easy? I hope so, but again, I know some of you guys are struggling. I feel it. You're just too shy to raise your voice, but see me, we can work together on these questions, more questions, but what's coming up is harder. So you need to get ready. 6.3, we will start factoring this kind of trinomials, not 1 in the beginning, and not you cannot get this GCF out. Like if this was 16, you cannot get this 5 out because 16 is not divisible by 5. Then how do you factor this? Okay? So you may not be lucky to get 5 out sometimes. Well, how would you factor it? It's coming up next on Monday. Okay? All right. Have a good weekend. Please, if you're late, please make sure you sign up